What's up, everybody? Today we are working on probability, but we're working on representing the sample space. Now, yesterday we did some sample spaces, and we did some sample spaces for simple events, meaning there's only one event happening, like spinning a spinner once, rolling a die once, um, flipping a coin once. But we also have things called compound events, and uh, compound events are where they have two or more events, and we have to find the probability that one outcome will happen in these two or more events. And this will make more sense as we're going through it. But I need you to understand what compound events mean. So we'll go right into this. So remember what sample space is. So sample space represents all possible outcomes for a specific scenario. So let's say I was hiding a car underneath one of these cones. Okay, you would have the total possibilities, or the sample space from everything you can choose is you could choose either cone 1, cone 2, or cone 3. All right, there are three possible there are three elements in this sample space. Now let's look at this rolling a die. Rolling this die, if I were to roll it once, which is a simple event, the sample space would look like this. You can roll a 1, a 2, a 3, a 4, a 5, or 6, which is 6 elements in this sample space. Okay, there are 6 total possibilities that could happen if I roll a die. And for the cones, there are 3 total possibilities that I could choose from whenever I'm trying to win the car underneath. Now, we can represent sample spaces for simple and compound events. And one things that we can do is that you've seen me do is a list. But when we go into when there's 2 or more events, we have to use other methods to display our thinking. And so there are 3 different methods that we are going to be talking about. We have tree diagram, just like you see here. Whenever this is the diagram for flipping a coin 3 times, things that could happen. We have a list. This is the list for flipping a coin twice. And we have a table. This is the list for flipping a coin twice, which is the same. This is the table for flipping a coin twice, which is the same kind of as the list, but in a different method. And so we're going to go right into this. This says represent the sample space. This sample space. How could we represent the total possibilities if the first thing we do is roll a die, and then the second thing we do is flip a coin? And so I encourage you to pause the video and see if you can come up with a method on how you could either list or represent the sample space, which is all total possibilities that could happen. Can you list all of the possibilities? I encourage you to take at least 4 or 5 minutes, 3 to 4 minutes, to see if you can at least list some of them. And then I'm going to show you an easier way. All right. So hopefully you have paused the video and you've tried that. And I'm going to show you a way. So first thing we're doing is rolling a die. So the first thing that could happen is I could roll a 1. And if I roll a 1, I can flip a heads, or I could roll a 1 and I could flip a tails, right? Is that it? I can roll a 1 and get a heads, roll a 1 and get a tails? Yeah. I can also roll a 2 and get a heads, roll a 2 and get a tails. I could also roll a 3 and get a heads, and then 3 get a tails. 4 get a heads, and 4 I can also then get a tails. So this is the first event that you're seeing here on the left side, and the right side is the second event, which is flipping the coin. And so I can keep going because I haven't done my 5s or 6s yet. So I can go do a 5 and a heads, and then I can also do a 5 and then flip a tails. And then I could roll a 6 and get a heads, or a 6 and get a tails. Okay, so this right here would be considered my list. How would this look like in a tree diagram? Well, in a tree diagram, I'll have different trees based on my sample. The amount of trees that I have would be based on my sample space of the first event. So if my first event is going to be my first, so this is going to be the tree diagram. Okay. My first event is going to be rolling a 1, and then I could also do a heads, and then I could also do a tails. And so this line right here represents rolling a 1 first and then getting a tails, rolling a 1 and then getting a heads, And then this line down here represents rolling a 1 and then getting a tails. Now, this right here is the tree diagram. This is a list to help you understand what this tree diagram is saying. Okay. And then I can also roll a 2, get a heads or tails. Roll a 3, get a heads or tails. Roll a 4, get a heads or tails. Roll a 5, get a heads or tails. And then roll a 6, get a heads or tails. And so there are 6 different trees here, and the trees are split up that way because in my first event, which is rolling a die, I have 6 different possibilities in my sample space. And so this one, let's see what this one represents. It represents a 2 and getting a heads. And then this line right here represents getting a 2 and then a tails. All right. So I'm not going to go through all of those because you basically understand. I just want you to understand what each of these mean. Each of these, not all of these, this isn't one outcome, one outcome, one outcome. This right here is an outcome. And then this right here is an outcome. And that's represented right here. Okay. All right. The next thing you can do is you can also make a table. So I can get a heads or tails for the second event. And then for my first event, I can get a 1, 2, 3, 4, 5, 6. All right, so I have a 1 here, 2 here, 3 here, 4 here, 5 here. Okay, so this is the second event, and this is the first event. It doesn't really matter which way you put it, just the table would look a little longer or wider depending on which way it goes. And so this right here, and whatever you have, you basically just put them together. So I can get a 1 and then a H, a 2, and then an H. Notice that the H's are staying here, the 2, okay. A 3 and then an H, a heads. Roll a 4 and then flip a heads. I can roll a 5 and then flip a heads, and then I can roll a 6 and then flip a heads. Or I can roll a 1 and then a tails, a 2 and a tails, a 3 and a tails, a 4 and a tails, a 5 and a tails, a 6 and a tails. Okay? But no matter what, think about, let's see how many. This kind of looks right here to me. It kind of looks, this right here kind of looks like a multiplication table to me. And if you look, how many different outcomes do we have? We have 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12. Well, let's see. The first event has a sample space of 6. First event. And then the second event has a sample space of 2. And our total in our sample space of these two together is 12. So our sample space, whenever we're taking compound events, and we would just want to find the total in the sample space, is we could just multiply the sample space for the first event, sample space for the second event, and then if we have a third event, we can even multiply the sample space of the third event, and we'll get the sample space for the compound event. Okay? So let's go over another problem. This says, how can you represent the total possibilities of one? First thing you're going to do is spin the spinner. Second thing you're going to do is roll the die. So I encourage you to take those 2 to 3 minutes. This is the only way you're going to learn. The 2 to 3 minutes or 3 to 4 minutes, and try to work this out using these different methods that you have written down in your book so that you can reference later. So I'm going to give you some time for that. So pause the video and see if you can represent this sample space. All right. Well, let's see it. So first we're going to spin a spinner. On this spinner, we have red, green, blue, and orange. And then here we have 1, 2, 3, a 4, a 5, and a 6 on the side. Okay? So let's do our list. Our list is I can get a red and then a 1, a red and then a 2, a red and then a 3, a red and then a 4. I can also get a red 5, a red 6, and I think that's it. I can't get a red 7 because I can spin the red, but I can't get a 7 on just one die. Okay. And so let's go into it some more. So I can also get a green and a 1, a green and a 2, a green and a 3, a green and a 4, a green and a 5. And then I can get a green and a 6. And I could essentially do the same thing for orange. Orange 1, orange 2, orange, and then a 3, orange, and then a 4, orange, and then a 5, orange, and then a 6. And then I could also do the same thing for blue. I can get a blue 1, a blue 2, a blue and then a 3, a blue and then a 4, a blue and then a 5, and then a blue and then a 6. So how many are here? 6, 12, 18, 24. 24. And so I can also make a tree diagram. So my tree diagram, the tree diagram will have as many trees as the first event has. So I could first do a red. So this is going to be the first event, and these will be the second event. I could first do a red, and then I could do a green, and then I could spin for the first one, I could also spin an orange, and then I could also spin a blue. But if I spin a red first, I can get a 1, and then I can also get a 2, and then a 3, and then a 4, and then a 5, and then a 6. And then if I spin the green first, I can get a 1, 2, 3, 4, 5, 6. So this line right here means I can get a red 1 first. Not first, but I can get a red 1. That's a possibility. And then the second line right below it means I can get a red and then a 2. Okay, and I'm hoping you can get it from there because I really don't want to have to repeat the list process, but you need to know how to read these tree diagrams. So I can also get an orange 1, an orange 2, an orange 3, an orange 4, an orange 5, and an orange 6. I could also do blue 1, blue 2, blue 3, blue 4, blue 5, and blue 6. Okay, and then how would I do this as a table? So as a table, I would put the outcomes for my first event. I could do it here. So let's just draw a little table here. I could do red, green, orange, blue. And then for my second event, I can get 1, a 2, a 3, a 4, a 5, or a 6. Okay. And I can make these lines or not make these lines, whatever helps you. For me, it helps a little bit. So I can do a red 1, a red 2, a red 3, a red 4. Why do I put a red 4 here? Well, one, because the rows are for red, and the column, this specific column that this uh, uh, cube, this square is in the 4 column. And then I could do a red and a 5, and then a red and then a 6. Green 1, a green 2, a green 3, a green 4, a green 5, or a green 6. And so I can repeat this and fill out the whole column. And if I wanted to know how many were in the sample space here, I would just, without counting and listing everything, 4, 5, 6, like instead of doing that, I could say, well, in the first event, there are 4 different possibilities. And then in the second event, there are 6 different possibilities. So in the compound event, meaning we're trying to find if it happens one after another and find a specific instance that happens, like the probability of green 1, rolling a green first and then a 1, we would just multiply these two. Okay, and we get 6, 12, 18, 24. And if I wanted to know the possibility of getting a green first and then a 1, well, there's only one favorable outcome, and so that's a 1/24th outcome. Okay, a 1 out of 24 outcome. There's only one green 1. But I can also say, what's the probability of rolling a green first? And that would be 1, 2, 3, 4, 5, 6. So that'd be 6 out of 24, which would be 1/4 if I divide by 6. Okay. And that's why representing this sample space is important, because if you forget this, hopefully you're learning this multiplication here of the sample spaces, sample space possibilities, gives you your denominator, your total possible outcomes. If you forget that, you can always refer back to this tree diagram table and list. Okay. So here's one. It says flipping the coin and spinning the spinner. Well, I could flip a heads and then a red, a heads and then a green, a heads and then a blue, and then a heads and then an orange. And then I could also flip a tails first and get a red or a green, a tails and then a blue, and then a tails and then an orange. So this says this says heads and then a red. This says heads and then a green. This says heads and then a blue. And this says heads and then an orange. Okay, so there's 4 outcomes here if I flip a head first. Or if I flip a tails first, there's another 4 outcomes. A heads, a tails and a red, a tails and a green, a tails and a blue, and a tails and an orange. Okay, so here's my tree diagram. Here's my list. Now I just need it as a table. Red, blue, orange, green. And so I could do a heads red, a tails red, a heads blue, a tails blue. I can also get a heads orange or tails orange, or I can get a heads green or tails green. Okay. Notice that there's 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. All of these are representing the same situation. The total possible outcomes if I flip a coin first and I spin a spinner second. And so in the first event, I have 2 in the sample space. In the second event, I have 4 in the sample space. So it only makes sense that my total possible outcomes would be 8. And if I wanted to know the possibility of rolling a heads first and then a red, well, that would be a 1 out of 8 chance because it's right here and nowhere else. So for your assignment today, what you're going to be doing is you are going to be taking a choice of making frozen or ice cream and making your favorite ice cream cone. You are going to choose one flavor and one topping based on the images I give you, and you are going to create a table, a tree diagram, and a list of all the possible combinations and outcomes that could happen if you choose one flavor and one topping. And good luck with it. And let me know if you need any help. I'd be happy to help.